Hi, everybody, and welcome back to Chee-Tash. My name is Chris, and today we're going to be talking about Chapter 3 from the book Clean Code by Robert C. Martin. And we're going to be talking about functions today. If you guys remember last time, we talked about meaningful names and how to name certain classes, how you should name your methods, and just making things very simple and readable so that people who are working on the same code base that you're working on can understand the intent and the functionality of your code just by reading the names of certain variables, functions, and classes. And today we're going to kind of piggyback off that idea of functions, and we're going to have this whole chapter dedicated to functions. And we're going to kick things off by talking about small. And this was the first section of this chapter where Robert talks about the size of functions. And I can say this from experience that a lot of methods and functions of classes that I have worked on have been very, very big. Very, very big. And a lot of the concepts in this chapter I have most certainly have violated. But in a way, I guess that's like the first step, right? Like, I guess the first step is admitting that you have a problem, right? So I think it's an important first step to actually realize then based on reading this book and then comparing it to what I've been doing, knowing what I could improve. And one of those ways is making functions small. So this is, as Robert says here, it's the first rule. Functions should be small. And then the second rule is that they should be smaller than that. So we're talking something very, very small. Functions should hardly be 20 lines long. So they should really only perform one function. We're going to get to this a little bit later, but they should do one thing. And they shouldn't have any sort of side effects to them. So they shouldn't be doing multiple things. They should do one thing. They should do it well. They shouldn't take that many input arguments. And they should just be very, very, very small. And named properly as well, like we talked about in Chapter 2. But there's a couple other things. Functions should be transparently obvious. And functions should lead to the next function in a compelling order. So if you have an example of processing a payment, right? So you would have one function that's intake order. You would have another function that says calculate total price. Then you'd have another function that says get fastest transportation route. And then you'd have another function that says, print invoice. So in the context of placing like an Amazon order, you can see how you have these 4 or 5 separate functions that I just named, but they all kind of follow a very logical order to the payment process. Hey, intake order information, get address information, get total item cost, get the fastest transportation routes, print receipt. So they're all, first of all, the names of them too are kind of transparently obvious what you're doing. And then secondly, they all kind of lead in a compelling order, and they all, most likely, they all do a one thing. So continuing on this note, Robert talks about blocks and indenting, and that this is what he says. This implies that blocks within if statements, else statements, while statements, and so on should be just one line long, and probably that line should be a function call. And this also implies that functions should not be large enough to hold nested structures. So you can see on the left screenshot there that this is very nested, and this is very indented. So every time you nest something within something else, so here you have an if nested inside an if, nested inside another if 4 times over, you see that an indentation is made to to illustrate that that if is within the parent if. And this is kind of what Robert Martin says to avoid. You don't want unnecessary or overly complicated nesting structures in your functions. They should not be nested that deep. And again, they should be very, very, very small. Now look at it on the right over here, where you extrapolate out the block. So instead of doing all the conditional checks in one function, you have here one process order function, and then you do your checks outside of that function. So you see, oh no, actually they're not doing that. They are process. So within process order, they're not nesting. Okay, so no, everything's within process order, but they're not nesting those conditional statements within each other. So they're not dependent. So the order, so the customer, checking on the customer is not dependent on the order not being null. We're just doing it all synchronously, all in one line. Right? And this is kind of what Robert Martin would rather you do, not have these if statements nested. Okay, I got it there. Which I guess you could also extrapolate out, and we're going to talk about that, where you can extract things from a function if it's way too big, and you can extract it out into separate functions. So maybe you can do these conditional checks even in their own functions and just kind of call it all within process order. Potentially, you could do that. Oh, and there we go. I had some text there. Blocks within the if-else, this is kind of what I said earlier, should be one line long. That one line should be a function call, adds documentary value. The indent level of a function should not be more than 1 or 2. So you can see on the left, it's like 4. On the right, that's nice. It's only indented, one time. So again, we talked about this, how functions should really only do one thing, and they should do it well. They should do it only, says Robert. So take that process order function from previously. A function may have different function calls within it, though, but is it doing one thing or multiple things? So if you take this function process order, you can see that it has multiple function calls within it, but is it doing one thing or multiple things? So you would have to look inside of each of these functions, validate, order, calculate total, update inventory, to make sure that these subsequent function calls aren't doing more than one thing. So is validate order, is that all that's doing is, hey, make sure that the addresses line up? Calculate total, hey, is that just doing simple multiplication? Is it not doing anything else? And so on and so forth. Did I have another bullet point here? Yes, I do. And then if you can extract another function from it with a name that is not merely a restatement of its implementation, then you should go ahead and do that. So think about if I had this process order function here, and instead of these 4 function calls, I had all the code within this function. This is kind of violating some things that we've already talked about just like a few minutes ago. Functions should be small. They should be smaller than that. They should do one thing. They should do it well. They shouldn't be indented that much. They shouldn't have that many nested structures within it. And maybe this screenshot is the best possible way to refactor that sort of code. So, continuing on, Robert Martin says that you really should only have one level of abstraction per function. And by abstraction, this means that you basically shouldn't, I almost think of abstraction as the function, I know it sounds weird to say that, but the functionality of a function. But it's really kind of stemming off of that principle of a function should just do one thing. Kind of. And I'm trying to explain abstraction in the best way possible here, because I also put here you should not mix levels of abstraction because this could lead to confusion. Oops, let me go back. But I guess abstraction means you shouldn't, within a function, you shouldn't have it be doing multiple things. So you have one level of abstraction here, validate order. You have another display order. Let me actually, here in Robert's book, he kind of talks about, in order for our functions are doing one thing, we need to make sure that the statements within our function are all at the same level of abstraction. It is easy to see how mixing levels of abstraction within a function is always confusing. Readers may not be able to tell whether a particular expression is an essential concept or a detail. Worse, like broken windows, once details are mixed within essential concepts, more and more details tend to accrete within the function. Gotcha. Okay. I got you here. So now I'm wondering, okay, so there's that one. This one is, I feel like maybe is okay because abstraction, one level of abstraction, so you're not going like nested. And then in here, abstraction, maybe what abstraction means here in this case is maybe this if else, because you're going to be doing two completely different things depending on this if else. So it would be almost better to take this if else conditional and kind of maybe make this into like maybe two separate function calls here. Like, okay, check if order is valid, and then do these three functions in a separate function call, calculate total, update inventory, then generate invoice. Or if it's not valid, then do the send payment error with notification. And then no matter what, you're displaying the order summary. So maybe that's what's meant by abstraction in this case, is abstracting it out. You shouldn't, and again, it kind of goes along with the single responsibility principle in that it just shouldn't be doing too much. Yeah, sorry if I am confusing anybody out there. But that's kind of how I see abstraction, is essentially an offshoot of it should only do one thing. So reading functions. So when you read a function, you want to read the code like a top-down narrative. And what Robert talks about is this TO, a set of two paragraphs, which two is used to define procedures or functions in, I think it was Arduino, I believe. So each two defines that level of abstraction and refers to other twos as necessary. So if you are writing a story, these twos are used to write a story of what the function is essentially doing. So to include process order, we pass in an order from a customer and need to validate it, calculate the total price, update inventory, and generate an invoice that gets printed. To include validation, we need to verify the order has a unique identifier and is not null. So you see how the top two is almost like the summary, the introduction. And then each subsequent two is describing what you are going to be doing, what the function calls that you're making, and what they're going to be exactly doing. So you got to validate, you got to calculate, you got to update, you got to generate, right? So each successive two, you're describing that. So, okay, so validation, we need to verify the order has a unique identifier. Calculation, we got to multiply price by quantity. And then update, we got to post a HTTP call to this API that writes to the database, what have you. So thinking of functions or your code in general as a story might be better mentally for you understanding the code than just think of it as, oh, this is just a code base, when really you could be thinking about it like, oh, it's a story. So what about switch statements? Well, switch statements by nature do an n number of things. And switch statements can be good. They can be good, but they could be even better if you can use them as part of a class by taking advantage of something called polymorphism. And polymorphism means that objects of different types can be treated as objects of a common base type. Kind of like an essential tenet of object-oriented programming. So you have this payroll class, and you're trying to calculate pay, and the pay is going to be dependent on an employee. So you have commissioned employees, you have hourly, and you have salaried. And you're going to call different functions based on that. But there's a better way to write this. And I guess, first of all, there's several issues with the way that it was written in the previous slide. First of all, this could potentially turn into a large function because as new employees are added, that function is going to grow. It does more than one thing because it's going to be calculating pay, but again, it's going to be doing different calculations based on different employee types. So it violates the single responsibility principle. It violates this principle of open and closed, meaning that functions should be, or classes should be open for extension but closed for modification. Because if you start to add employee types to this, well, now you're modifying it and it could potentially grow. And also, other methods will have to have this same switch statement for employee type determination. You're going to have to duplicate the structure whenever you need to figure out, oh, what employee type is this person? So it's going to get repetitive. So the solution is to bury the switch statement in an abstract factory. So you see here, you have a public abstract employee class, which means that you can't make objects of this employee, of the employee class, but you can have different types of employees. And that's where this employee factory is going to come in, because you're going to be able to make employees based on this employee record. And you can implement that employee factory to produce whatever type of employee you need. So you can have commissioned, hourly, and salaried employees, but this is going to be like you're creating objects. Because you see here, we're now utilizing this new keyword. This isn't a function call anymore. This is a constructor. And ultimately, this is returning an employee, right? But this switch statement, you can see, is buried within this class, which implements an interface. So people aren't normally going to see this make employee method. They're not going to see that. And then later, you can use the methods belonging to the employee abstract class to then calculate the pay just by calling the method that's within that specific employee type class. Because you see here, a commissioned employee is going to extend this employee class, if you guys notice that here. So it's going to have this int type. It's going to have these methods that it'll be able to override and implement in its own special way, because the pay for a commissioned employee is going to be different than the pay of an hourly employee, so on and so forth. So burying the switch statement within an abstract or within an interface to hide the functionality. So another thing with functions is that they should use descriptive names, and this is known as Ward's principle in clean code, is you know you are working on clean code when each routine turns out to be pretty much what you expected. And what is expected is you can expect a function to do what its name is saying it's doing. So deliver pay. You're expecting that it is delivering pay. It's making a post to that employee's a record in a table in a database. So suffice it to say, it's a pretty good chance that it's doing that just from reading the name. Also, the thing with names is long and descriptive beats short and not descriptive. And also long and descriptive beats a long comment. So if you're afraid that, I have this descriptive name and it's really capturing what my function is doing, but it's kind of long, Robert says err on the side of that long. You'd rather be very too long than too short and just not even descriptive at all. Next up, this is where we're going to get into the function arguments. So this is another rule that I kind of violate a lot. Robert says the ideal number of arguments for a function is 0. Next is 1, and then so on and so forth from there. And this is something that was very new to me because I have functions with multiple arguments, but I get where Robert says here that arguments add a different level of abstraction potentially. And you can kind of see that in these two methods, include setup page and then include setup page with new page content. All of a sudden, testing becomes a little bit different with multiple different arguments because you have to take in different test cases now. Also, a function is not going to be as intuitive. You're not going to as easily know what the function is doing once you start introducing the arguments to it because, include setup page, no arguments. Well, it includes the setup page. Somehow the setup page is being added to something. But when you include setup page and then new page content, all of a sudden it kind of gives you pause and you have to start to think, well, what is new page content, right? So how many arguments they're taking in. So monadic, 1 argument, dyadic, 2 arguments, triadic, 3 arguments, so on and so forth. Robert talks about how there's 2 common reasons to pass a single argument into a function. So if you take that argument, so deliver pay, right? You're taking in the information from that employee object to set the pay for that week for the employee. So your question about that argument. So, which is kind of, I guess, what I was just doing there. So I'm sorry. Operating on that argument would mean that you're transforming it into something else and then returning it. So you're taking in, I guess you could be taking in maybe like the base pay for an employee. Because if they're hourly, maybe they work different hours in the week. And so you're going to take in their hours worked and then multiply it by something and then return that something. Or you're taking in the employee, right? And then you're going to transform the base pay field of that employee into something. Yeah, as an example. But there's also another one, another way to act on arguments that are being passed into a function, and it is through this thing called an event, where Robert describes it as there being no output argument, but there is an input argument. So in this form, there is an input argument but no output argument. The overall program is meant to interpret the function call as an event and use the argument to alter the state of the system. For example, use this form with care. Should be very clear to the reader that this is an event. Choose names and contexts carefully. So an event, again, there is an input argument, but there's no output argument, so it doesn't return anything, but it does something. Like maybe it prints something, right? Prints an invoice. And maybe that's just logging it out to the screen, or saving it to a database, but it's not going to return it for the purposes of like any other function there. And Robert says here, try to avoid output arguments without a return value, especially with transformations. So if you transform something, most oftentimes you want to return that. You don't want to just transform it just right in the function without returning it, which I guess kind of makes sense. You don't want your functions to have any sort of external side effects, if you will. So if you're going to have output arguments to a function, make sure you just return them. Oops. There we go. Flag arguments. So passing a Boolean into a function is a terrible practice, and I, again, guilty of this. Passing in, hey, if this flag that I pass in as an argument is true or false, we're going to do one or the other thing. No, just separate it out. Dyadic functions, we kind of just talked about this. When you introduce two arguments into a function, you sometimes have to take a slight pause. Single argument is fine. Maybe you still have to take a slight pause. I know I mentioned this earlier, but it probably still has a nice cohesion to it. And maybe I was being a little unfair earlier when I said, oh yeah, you got to kind of stop and take a pause to include setup page. What does that exactly mean? But when you start to introduce 2 and 3, it becomes even harder to understand. And think about the method, like especially if you're doing JUnit tests and assert equals, where you have a message, expected, actual. And you kind of have to stop and think maybe a little bit, especially if you're utilizing this method in your tests. How many people here have gotten this order wrong? I've gotten this order wrong many times. I run the test and all of a sudden it's like, God dang it. Okay, the message is the first argument, then the expected, then the actual. So yeah, things definitely can get confusing. So argument objects. So you can pass in arguments to a function, and they can be pretty primitive. You know, strings, ints. Strings are not primitive, but yeah, ints, doubles, floats, what have you. But sometimes you can take arguments and you can pull them into a class of their own. So in this case, where you have a make circle method, double x, double y, double radius, well, why not extrapolate the x and the y, because those are coordinates, right? And you could make your own class called point and call it center, and point has the fields double x and double y within it. So now this kind of maybe reads a little bit better. Make a circle, pi r squared, right, is to find the area of a circle. Not that that's what this is doing, but you have a point center and you have a double radius now. And this is what Robert says, 2 arguments might be part of a concept that deserves a name of its own. And essentially he just says to watch out for that. And if you can extrapolate it or abstract it out, then a lot of times it's easier to do that. Oops. So now what about argument lists? Functions with more than one argument are sometimes treated identically. And this, Robert says, is the equivalent of passing in a type list. So you have a public string format method with a string format argument and then an object array ... of arguments. Functions like this can be monads, dyads, or even triads. But I think what he's saying, arguments, right? But it's going to seem like it has a lot because you can pass in many, many, many different arguments here. That's what that object and the 3 dots arguments. You see this a lot with like maybe, like HTTP post requests. Like you have an object of arguments or like an object of headers, I believe it is. So if the variable arguments are all treated identically as they are in the example above, then they are equivalent to a single argument type of list. So that's essentially what he's saying here. Yes, you can have like multiples here, but you're essentially just treated as one argument of a type list. Now getting into specifically what you should name your methods. Verbs and keywords. Verbs are great because remember how we said classes should have kind of noun names. They shouldn't be verbs, but functions should be mostly verbs because they're doing something. So monads with an argument do very well. You do very well naming them with a verb and a noun pair. So, deliver pay. So deliver pay is the function call, but then you're passing in like an employee, right? That's pretty good because you have a verb delivering the pay, but then you also have the noun of the employee. But you can even name functions to include the order of the arguments. So like assert equals, you could extrapolate that out or change that to assert expected equals actual to go along with the ordering of your arguments here. Expected comes first and then actual comes second. And I actually kind of don't mind this. I know it's longer than assert equals, but it does make it very clear. Okay, the first argument is expected. The next argument is actual. And this is kind of what I alluded to earlier. Functions should not have side effects, and side effects are lies. Side effects are lies. So what I mean by side effects is they do extra things that are sometimes not intended and sometimes you don't want. Your function this is Robert. Your function promises to do one thing, but it also does other hidden things. Sometimes it will make unexpected changes to the variables of its own class. Sometimes it will make them to the parameters passed into the function or to the system globals. In either case, they are devious and damaging mistruths. Be very wary of them. So in this one, we have a shopping cart class, right? We've got this add item method. We've got update total price. We've got send notification. And we've got some potential unintended side effects. I guess we don't really know what's happening in update total price or send notification, but we do have this items.add item. So we're adding an item to a list, plus we're updating in total price, plus we're sending notification. So it might be best to not include that items.add because already this function might be doing multiple things here with an unintended side effect, potentially an update total price or send notification. But also maybe just we don't want to be adding it to the list in this function. So just remember that. Be wary of how many things your functions are doing and make sure that they're not doing anything more than what they're supposed to. That's kind of like the main point of this chapter. Your functions should do one thing well. Please don't have them do more than one thing. This was an interesting concept of temporal coupling. So temporal coupling means that the functioning of a piece of code depends on the order or timing of method invocation. So when things kind of depend on other things having to be returned or run first, that's kind of temporal coupling. And this creates a lot of hidden dependencies, which are not good because if you potentially change one area, if it's temporally coupled to another area, you might have to change that, or you might not even be able to change it. And yeah, it just makes it that much harder to change. So be careful if you have function calls that depend on other function calls or pieces of code that depend on other pieces of code, because if something changes downstream from that coupling, you're going to have to potentially make a bunch of other changes. All right, so output arguments output arguments. If you have to check the method signatures to see if something is an input or an output, you should maybe rewrite it to be more clear. So an output argument, input arguments are what's being passed into the function. Output arguments are what is going to be returned. So in this example, in those, the second and third bullet point there, can we tell what's the input argument and can we tell what's the output argument? In append footer, you might not really be able to know unless you look at the method signature. And that's what the third bullet point is. So that's like if you do command click in IntelliJ or Eclipse, like in your favorite IDE, and you can look at the documentation for append footer, and you can see there, okay, string buffer report. I think this is probably a output argument, I would assume. That's what I would kind of maybe assume. Because you're appending footer to the report, and then you're returning the report, right? But Robert kind of talks about how output arguments should be avoided. If a function must change the state of something, it should change the state of its owning object. So input arguments are fine, but output arguments should be avoided. So it's taking something within, taking an argument, and it's going to change it and modify it, then return it. Yeah, it shouldn't be doing that, but it can, and it's allowed, preferred. I just used like a bunch of words there. It's preferred if it changes the state of its owning object. So if the method belongs to a class, it's okay to call that method and then act or modify the state of something within that class. But if you just have like a random function call that's modifying the state of an object, that probably should be avoided. So I think this was an example of, okay, we have this rectangle class right on the left, and we have this function there, the method calculate area and perimeter. So it's taking in this output argument, output, and then it's going to calculate the area and the perimeter. But you see here, it's not returning an area or a perimeter. It's setting it to the output argument. You guys see that? It's setting it to the output argument so that you can just call the output arguments dot functions or set or get methods, and you can get the area and get the perimeter, and that's what's happening on the right-hand side there. You see, we're not returning an output argument. This is a void method, so it's not returning anything, but it's acting on the output argument and modifying it. And you can see that when you use the getter methods there. So this would be like a good example of the previous slide where you're avoiding output arguments. So now command and query separation. What is this? What is this concept? So functions should either do something or answer something, but not both. And again, kind of building off this concept of your function should really only do one thing and they should do it well. So they should either be doing something or answering something. So they should either be, changing the state of an object or returning some information on an object. So like in the previous example, it's changing the state of that output argument. Or it could return some information about that object, like when you call a getter method. Like, hey, get area. It's getting some information about that object. But if you see in the second bullet point, if you have set with the arguments username and Uncle Bob, what's really going on there? This is the main point that Uncle Bob here is trying to make, is that you should separate the command from the query. So the command from the query. So checking if the attribute exists would be the command. So you're checking if the username exists. If it exists, then you set the attribute to Uncle Bob. Then you set the username to Uncle Bob. That's the query. And query here can mean like a database call, right? You're going to be changing something in the database, changing the username to Uncle Bob, right? And that's what he's saying here. To go along with the fact that functions should do one thing, you should separate out the command from the query in the function. And you should kind of have them do, you should kind of have a command function and a query function. Next, prefer exceptions to returning error codes. And you can see where you could get into the weeds with returning error codes. Again, something that I've done before. When you return an error code, you kind of have to catch, or you kind of have to check for each subsequent error code. And it could potentially get complicated. The caller must deal with the error code right away. You have to check, okay, what error code did I get? Did I get a 200 or a 400 or a 404? So instead, you should use exceptions because this allows you to have a happy path and an alternate path. So if you have exceptions, you can catch them and try catch blocks, and then you can have a path out of that exception. You can handle that exception. And you can still have your happy path if all the things go well. So if everything in that screenshot in the try, if everything just looks good, no hiccups, then it's just going to print, right? But if it does end up catching an exception, you can handle that gracefully. But there's even something here. Yeah, this was the next slide here, because he says that about exceptions, but then he also says you want to put the bodies of the try and the catch blocks into functions of their own. Right. So instead of having, like in the previous example, like you have this try catch, he says that Uncle Bob is saying here, you should hide this implementation within a function itself. So you hide it within this, specifically within the divide numbers function here, but perform operation is what's called. Within perform operation, you're calling divide numbers, and then within divide numbers, that's where your try catch is. So you're kind of hiding the implementation like we did with the switch case. So remember how we said functions should do one thing? Well, error handling is part of that one thing. So if you're going to have a function that does error handling, then have it do just that. But be wary of dependency magnets like errors, because if many classes are using errors, and if some change, that means that all the subsequent classes that are importing those errors that you created will have to change as well. And he gives this example of the error.java enum. Right, so this is, I should have probably included a picture of this, but this enum, kind of like a constant, it's got OK, invalid, no such, locked. Classes like this are a dependency magnet. Many other classes must import and use them. Thus, when the error enum changes, all these other classes need to be recompiled and redeployed. So maybe, I don't know if this is like a readily available enum already in the JDK, or if this is just something that's common that developers do. They create like an enum of an error enum, and then they think, okay, we have these constants that we're going to use and we're going to check for these errors, which is cool. But, you know, again, your caller is going to have to handle the error right away and check for the error code. So you shouldn't be returning those. You should be catching using try catches. But also when things change and you add something to the enum or you adjust the enum, all the other classes that import that enum are going to have to change as well, if that makes sense. Oh yeah, this is another big one. Another big one. Don't repeat yourself. Don't repeat yourself. So this is where you can take code and extrapolate it out into its own function if you find yourself reusing that piece of code multiple times. And this is what Robert says is the root of all evil in software programming. And definitely things can be refactored. If you find yourself repeating your code, it can be refactored. So special rules from Edsger Diskra. I don't know if that's like a Swedish or a Danish name, but this gentleman goes like above and beyond. So he says that every function and every block within a function should have one entry and one exit, only one return statement in a function, no break or continue statements in a loop, and never any go-to statements. And you should keep your function small. Or sorry, that last bullet point is Uncle Bob's. So these aren't bad rules to live by, but if you do a good job of making your function small, super descriptive, you're following some of the rules that we stated earlier, like you should really only do one thing, not a lot of indentation or nesting, you can kind of get away with some of this stuff where, okay, you can have maybe more than one return statement. Maybe it's not a bad thing you have a break or continue. As long as you follow the other rules, there's other maybe more stringent rules that you could look the other way on. And Mr. Dijkstra's rules may be a little much, but they're not by any means bad. So, is this? Yep, this is my last slide. So how do you write functions like this? Well, as with anything, you get your thoughts down first and you try to solve the problem at hand, and then you go back and you reread it and you restructure it. And that's really kind of how I try to write code is I try to just solve it at first, and then you go back and look at it, and then you think, oh, yeah, I could change this a little bit, or I can make this a little bit nicer, or rename this here, or refactor this here. But to try to do it perfectly all at once, I think is a recipe for you just taking way, way too long to do it. And it's better to draft something and then go back, like have a rough draft and then go back and redo the rough draft. It's like the writing process, I guess. Like you're writing a book. You're going to have editors who take a look at your book and you're going to have to rewrite things. Just part of the process. And can it be painful? Yeah, it can be painful. But remember, like what we talked about it was the introduction or chapter 1, that you want to leave the code base in a better place than when you came into it, just for the sake of other team members that are going to be working on it as well. So to summarize, just a couple things. Functions are like verbs. They're doing things. Classes are like nouns. They're people's, places, things. And functions should be really just doing one thing. They should do it well. They should be small. They should return one thing, which in a lot of computer languages, you don't really have to worry about returning multiple things. But anyway, they should be small. You shouldn't have a lot of nesting. You shouldn't have multiple levels of abstraction in your functions. They should be well named, very intently named, and you should be able to infer what the function is doing from its name. And this is the art of programming. It's the art of language design, says Robert Martin, and that's kind of a big part of the battle is just how well do you name your stuff? How well can you convey that story? And this is a very interesting way to look at it. I didn't really look at it like this, but viewing programming as a story to be told rather than a program to be written, or your code is a story to be told, but not necessarily a program to be written. I mean, it is that, but it's also a story. And how you name things is a big part of that. So, with that, thank you guys very much. I know this was a long episode, and hopefully that made sense on some of the stuff I got a little bit tripped up on. Hopefully the stuff on abstraction especially made sense. Basically, just remember, guys, a function should really just have a single responsibility. And when you start getting into functions that do multiple things, that's where you have multiple abstractions, where you should probably abstract those multiple things out into their own separate functions. I'm just going to leave it at that. I think that's the best way that I can describe that. But guys, thank you very much for listening. That was Chapter 3. Next time, we're going to be back with Chapter 4, all about comments. check out the latest interviews on the podcast, the Chee-Tash podcast, and this was fun. Thank you guys very much for listening. My name is Chris. This has been Chee-Tash. Take care, everybody.